reading of the article Electric Sun Verified by Wal Thornhill. The article begins with a question posed by Fred Hoyle in The Nature of the Universe. Quote, "Is it likely that any astonishing new developments are lying in wait for us? Is it possible that the cosmology of 500 years hence will extend as far beyond our present beliefs as our cosmology goes beyond that of Newton?" End quote. NASA's IBEX, Interstellar Boundary Explorer spacecraft, has made the first all-sky maps of the boundary between the Sun's environment, the heliosphere, and interstellar space. The results, reported as a bright, winding ribbon of unknown origin which bisects the maps, have taken researchers by surprise. However, the discovery fits the electric model of stars perfectly. Voyagers 1 and 2 reached the boundary of the Sun's influence in 2005 and 2007, respectively, taking measurements as they left the solar system. Before IBEX, there was only data from these 2 points at the edge of the solar system. While exciting and valuable, the data they provided about this region raises more questions than they resolved. IBEX has filled in the entire interaction region, revealing surprising details completely unpredicted by any theories. The meter-wide hexagonal IBEX monitors the edge of the solar system from Earth orbit by seeing the heliosphere's outer boundary in the light of energetic neutral hydrogen atoms, ENAs. The news releases highlighted the difficulties this discovery causes. Researchers had expected gusts in the solar wind blowing against the boundary to create 20 or 30% variations in ENA emissions, but the ribbon is 10 times that intense, a narrow band blazing across the sky like some Milky Way on fire. Charged particles have apparently become bunched along the ribbon near the boundary, but how they got there, quote, is still a big mystery. Our previous ideas about the outer heliosphere are going to have to be revised. The thing that's really shocking is this ribbon, end quote, says IBEX principal investigator David McComas of Southwest Research Institute in San Antonio, Texas. Quote, "I'm blown away completely. It's opened up a new kind of astronomy. It's amazing," end quote, says space physicist Neil Murphy of NASA's Jet Propulsion Laboratory in Pasadena, California. The expectations of NASA scientists are not being met because their shock front model is incorrect. The boundary that Voyager has reached is more complex and structured than a mechanical impact. The publicized image of the Sun's interaction with interstellar space is like the shock front of a supersonic aircraft. We are told the magnetic bubble of the heliosphere protects us like a cocoon as the Sun and its planets travel through the Milky Way. The concept of Langmuir's plasma sheath is entirely missing from this picture. It is electrically inert. IBEX has discovered that the heliosheath is dominated not by the Sun, but by the galaxy's magnetic field. Since the galaxy's magnetic field traces the direction of interstellar electric current flow in space near the Sun, it is a result that conforms to the EU model of galaxies and stars. It is necessary to acknowledge that the cometary heliosphere model seems reasonable when some images of stars do have a cometary appearance. Cometary phenomena are not a simple mechanical effect of an object plowing through a thin gas. Comets are an electrical phenomenon where the comet nucleus is a negative cathode in the Sun's plasma discharge. Examples of cometary stars are uncommon because stars are normally a positive anode in the galactic discharge. Characteristically, cathodes tend to jet matter into the plasma to form spectacular comas and tails. Stars may become comets in the process of electrical capture by a more highly charged star. It is a mistake to assume a cometary astrosphere model for all stars. However, a more fundamental conceptual error is to invoke stellar and galactic winds and the notion of tails being swept downstream Astrospheres and comets are plasma discharge phenomena. Electrodynamic forces govern them. Discussions about the external magnetic forces of the galactic wind dominating the shape of the heliosphere highlights a curious blind spot in astrophysics. In 1970, the late Hannes Alfvén counseled against the notion that magnetic fields can exist in space while ignoring their origin in cosmic electrical currents and their circuits. Alfvén predicted an imminent crisis in cosmology. I'm sure he never imagined that the scientific revolutions could take a century or more in this era of global communication. But specialism and specialist jargon is the enemy of communication, and the wide-ranging investigation needs to compose the big picture we call cosmology. And no scientist likes to admit their specialty is in crisis. For a more detailed perspective on the astrophysical crisis, I recommend my article, The Astrophysical Crisis at Red Square. There I wrote, Alfvén pioneered the stellar circuit concept, and it seems his wiring diagram is essentially correct but incomplete because it does not show the star's connection to the larger galactic circuit. Alfvén remarked, quote, "The stellar current closes at large distances, but we do not know where." End quote. Plasma cosmologists have supplied the answer by mapping currents flowing along the arms of spiral galaxies. It is but a small step from there to see that all stars are the focus of Z-pinches within a galactic discharge. Normally, the current flows in dark mode, so we don't usually see the spectacular bipolar wiring harness of hyperactive stars. Meanwhile, I explained all three rings of supernova 1987A in terms of a stellar plasma Z-pinch. Here we see the essential features of a plasma Z-pinch experiment, the details of the concentric Birkeland current filament cylinders, and the witness plate resulting from the galactic Birkeland current filaments in that cylinder striking the matter in the disk expelled from the star at the focus of supernova 1987A. The bright beads are like the effect of a ring of searchlights punching through a thin cloud. The tendency for pairing of the bright circular spots and the extremely slow expansion rate of the equatorial ring suggests the Z-pinch model is correct. A normal star will have the same Z-pinch environment as a supernova, but at a much lower energy. So instead of a brilliant ring of lights in the sky, astronomers detect a bright ribbon of ENAs caused by modest excitation of matter from the sun's stellar wind by the local galactic Z-pinch. This diagram shows a conceptual cross-section along the central axis of the stellar Z-pinch at the sun's position. Whether the double layer exists within or outside the heliosphere is unknown. The diameter of the encircling cylinder is unknown. That of supernova 1987A is of the order of a light year, which would make the diameter of the heliosphere more than 600 times smaller. Note that as a rotating charged body, the sun's magnetic field is not aligned with the interstellar magnetic field and Z-pinch axis. The sun's magnetic field only has influence within the tiny heliosphere, but it is modulated by galactic currents. Alfvén's axial double layers, DLs, have been included although their distance from the sun is unknown. DLs are produced in current-carrying plasma and are the one region where charge separation takes place in plasma and a high voltage is generated across them. The Z-pinch model offers a simple explanation for the giant ribbon found wrapped around the heliosphere. The Z-pinch is naturally aligned with the interstellar magnetic field. Solar wind ions are scattered and neutralized by electrons from the Birkeland current filaments to form ENAs coming from the Z-pinch ring, a giant ring around the solar system and orthogonal to the interstellar magnetic field. The Sun's heliospheric circuit is connected to the galaxy via the central column and the disk of charged particles. The current path is traced by magnetic fields. The open helical magnetic fields discovered high above the Sun's poles by the Ulysses spacecraft are supportive of Alfvén's stellar circuit model, and the solar wind would seem to connect to the broader disk of charged particles around the heliosphere. Given the detail in this model, we should expect, as more data comes in, that researchers may find in the ENA ribbon bright spots, filamentary structures, and movement of the bright spots consistent with rotation of Birkeland current filament pairs and their possible coalescence. The Science Journal reports the opinion of one of the researchers that, quote, sorting out the heliosphere's true shape will take more time. The geometry is tough. The shape is no doubt somewhere between the two extremes of ideal comet and pure bubble, but all agree that researchers will have to understand how the ribbon forms to know the heliosphere's true shape. End quote. That is true. But scientists will continue to suffer surprises while they have no doubt that the galactic wind and the interstellar magnetic field are the dominant forces that shape the heliosphere. Researchers are keen to see how changes in the solar wind affect the ENA observations as the Sun moves toward the maximum of its 11-year cycle. Such observations are very important. The solar cycle is controlled by its local galactic z-pinch, so any variation in ENAs may provide some clues about the origin of the quasi-cyclic variability in the circuit supplying DC electrical power to the Sun or solar cycle. The brightness of the ENAs should vary, probably out of phase with the solar cycle. In 1984, Alfvén predicted that his circuit model of the Sun there are two double layers, one connected to each pole at some unknown distance from the Sun or heliosphere. He wrote, quote, as neither double layer nor circuit can be derived from magnetofluid models of a plasma, such models are useless for treating energy transfer by means of double layers. They must be replaced by particle models and circuit theory. Application to the heliospheric current system leads to the prediction of two double layers in the Sun's axis, which may give radiations detectable from Earth. Double layers in space should be classified as a new type of celestial object. End quote. There is some other research to be encouraged by this ENA discovery which should throw further light on the Sun's electrical environment. The axial double layers should be detectable as nearby fluctuating radio and cosmic ray sources. In fact, their oscillation may modulate the current flow and be a source of this solar cycle. Already there has been a report of an unexplained high-energy cosmic ray hotspot roughly in the direction of the inferred heliotail. The energies of the cosmic rays are in the range possible by acceleration in a galactic double layer. Confirmation may soon come from observations of high-energy cosmic ray electrons. The electrons undergo synchrotron and inverse Compton scattering losses and thus cannot travel very far from their sources, which makes them sensitive probes of nearby galactic sources and propagation. If the diagram is close to the real situation, then we may expect cosmic ray electrons to arrive from the double layer in the opposite direction in the sky to the nuclear cosmic rays. The EU model is based on a hierarchy of repeated patterns of plasma behavior from the size of a galaxy down to a few centimeters in the laboratory. Therefore, it is subject to experimental confirmation, unlike most astrophysical theory today. So discoveries from space like this one should trigger experiments in plasma laboratories around the world instead of theorists wasting resources by conjuring up ever more complex and unlikely models based on invalid concepts of space plasma. IBEX recent results that have taken researchers by surprise have given yet more strength to the EU model, a model that confidently predicts that the shape of the Sun's galactic plasma environment is the hourglass, Z-pinch shape of planetary nebulae and supernova, aligned with the local interstellar magnetic field. The beautiful symmetrical patterns that arise in plasma discharges from very simple principles renders all modeling that ignores the electrical nature of matter and the universe worthless.